Now it's great to understand how two of these quantities will vary if two others are held constant. But what if I grab this thing tightly with my hands, which are warmer than the surrounding air and warmer than the bottle, warmer than the air in the bottle was, and squeeze it real well? Well, what's just happened? I've changed pressure, obviously. I've changed the volume. I crunched the thing down, and the temperature has changed due both to the crunching down, as we'll see, and to the presence of my hands. So that I started with some value of P, V, and T, and I ended with some value of P, V, and T. It's worth understanding that if I know the values of P, V, and T in any state, then I can find the value of N in that state. And then I know what N is, and I can use that to find values for the other state. Now, I'm not going to go through details of that. We'll see problems of that nature. Well, for example, if I know how much pressure I had at the end and also how much volume, then if I know the pressure, volume, and temperature at the beginning, I can determine the value of N, which I can then plug in with the pressure and volume I know at the end to find the temperature. Now, you might want to deconstruct that statement, but it's fairly obvious, and there's a slew of fairly straightforward problems you can do using that sort of reasoning. The intent here is not to show you the details of how you'd analyze one of those problems, but to give you the tools to understand the situation so that you can analyze it. Again, I don't think you're going to have any trouble with problems of the nature I just stated. You're going to see them in your book. So basically, if you know three of these four quantities, we can find the fourth, and that gives us a tool where we can compare two states of the gas, where we have two different values of pressure, volume, number of moles, and temperature.